All right, so we're going to find the volume bounded by these two curves, the sine and cosine curve, rotated about the x-axis. So we could put it on our TI, or remember that the sine and cosine have period 2 pi and quickly sketch them. So let's go put y equals cosine of x is our first guy, and sine of x is our second guy. And let's make sure our mode is in radians. It is in radians, so if I do a zoom 6, of course I'm going to see many oscillations, but we only care between 0 and pi over 4 for our x value. So let's go to window between 0 and pi over 4. And that looks a bit funky because my y values are so big. Let's zoom into like -2 to 2 because we know the amplitude of these guys is just 1. So it looks like they intersect at that pi over 4, which makes sense because when our sine and cosine for an angle equal, it's for the 45-degree angle, right? They're both 1 over root 2. So their intersection point is at pi over 4. We could even do second trace 5, first curve enter, second curve enter, and then the third enter will give me that intersection point, which is 0.785. And if I do pi over 4, it's that 0.7853999 blah 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 that they gave me. So we have our curve. Cosine was at the top, of course, sine was at the bottom. So I have this shape. I have the cosine curve and I have the sine curve like that, and they intersected the little leaf. Something like that was at pi over 4. And then x equals 0 is the left edge. So x equals 0, the left edge, bottom edge is the sine function, and starting at 0, and top is the cosine function. So there is our cos x at the top, sine x at the bottom. All right, rotate this guy about the x-axis. So about the x-axis, perpendicular cross-section would give me, first of all, about the x-axis, this guy down here for the image, something like that, and like this, if I were to copy it and imagine my pencil leaving off the residue down below. So we rotated about the x-axis. I'm going to make my cross-section perpendicular to the x-axis. So there's my shape. And I'm going to do volume is pi r outer squared minus r inner squared, and then my h. Since I'm making these pink slices go across, looks like my h is going to be a dx, which means my x values for the limits of integration would have to be at the left, which is 0, and at the right, which stops, the pink slices stop at pi over 4. So 0 to pi over 4 are my limits of integration. Then we got from the axis of rotation, which was x-axis, all the way to the end of the curve is my r outer. So there's my r outer. And then from the axis of rotation all the way to the inner curve is my r inner. And it looks like both r inner and r outer are vertical. So they're going to be y related. And because they're touching the x-axis, notice they're coming down and touching the x-axis. They're just touching the x-axis, so they're just y values. Nothing else but y values. So my r outer is a blue y touching the cosine function, minus my r inner is a green y squared touching the bottom function, which is the sine function. So let's get rid of those y's because I'm doing a dx problem. So I got pi 0 to pi over 4. If I put cosine in my first y, it's cosine of x squared. Don't forget your brackets to make dx belong to all of them. And then my other y is touching the sine function. So sine squared x. And I want to remind you guys of one identity from trig to finish the problem. We got cosine squared x minus sine squared x dx so far. And if you recall, cos squared theta minus sine squared theta from trig is actually just cosine 2 theta, double angle identities. So this guy is just going to change to cosine 2x so that you don't have any squares involved, so that your integration can be easy. From 0 to pi over 4, pi outside, dx next to it. So now my integrand looks much better with no squares to worry about. I do know the antiderivative of cosine is sine. However, I'm going to do a quick u substitution because this is cosine of 2x. So I'll say u is equal to 2x, du is equal to, du dx is equal to 2, which means du is 2 dx. And I will have both pieces accounted for. This guy is good. This guy is good from my du. That's going to be equal to pi cosine of u and then du over 2 for my dx part. And while we're at it, we could go ahead and change the limits of integration too. When x is 0, 2 times 0 is 0. I'm going back to my substitution to get those limits of integration. When x is pi over 4, my upper limit will be 2 times pi over 4, which is pi over 2. So I changed my limits of integration. Now I have pi over 2 outside, 0 to pi over 2, cos u du. Antiderivative is just sine u from 0 to pi over 2. So that's sine of pi over 2 minus sine of 0. That guy is gone. Sine of pi over 2 is 1. Don't forget we had the pi over 2 outside. So our final volume is just pi over 2. And that's it for the last example.